Hello, everyone. My name is Chris Berg. I am CEO and head chef of Data Kitchen, and I'll be your host for this webinar for the next 45 minutes to an hour. And so just a bit of housekeeping. So we will share the slides and the recording of this after we finish. Please feel free to drop some questions in the question box. I'll try to if I get time, I'll try to see those during the webinar. If not, I'll get them afterwards. Your questions are welcome. And thank you for taking the time to listen in today. So I'm going to turn off my webcam because who wants to see me? And you can focus on the slides. And so what's this webinar about? Well, it's about the idea of a data journey and why it's important and sort of why you should care. As I said, I'm a CEO of a company called Data Kitchen. We help people do something called DataOps, which is helping them deliver insight with lower errors and higher rates of change and higher productivity. And so we've been in business about 10 years, been profitable, and I have lots of experience both in software and data and analytics systems. I'm a technical guy. And so we're really going to talk about three things. So this idea of the missing piece. And so we at Data Kitchen wrote something called the Data Journey Manifesto, and we're going to walk through that. And then we're going to talk some principles behind it with some pictures. And then I'm going to do a short demo of our software that instantiates those principles in the manifesto in some software to give you a concrete example. So I guess why another manifesto in the world? And maybe that's all junk. And so one of the interesting things is about 6 or 7 years ago, we wrote the DataOps manifesto. And what's interesting is kind of showing you the term DataOps has actually gone up. And this manifesto, when we wrote it several years ago, we kind of we're talking about DataOps, but no one quite got it. This was for a conference. So on the flight back, I sort of wrote this and sent it to some people, got some comments, and we put up this web page. And now, I don't know, 10, 20,000 people have actually signed this. And it's interesting that even people just yesterday, Microsoft had an announcement on data fabric, and okay, some of the terms from the DataOps manifesto end up showing up in people's blogs. And so these things can have influence. And so I guess from my perspective, the idea of a data journey is fundamental. And so we need some way to think about it. And so from my standpoint, sort of reducing errors and defects, it's a very lean idea in the production of data insight, charts and models and data sets and integrated data sets and visualizations is the key to success. So errors and defects are a killer, and that's a very lean manufacturing idea. And from my experience and our customers' experience, sort of being shamed and blamed with problems that you didn't start, right? Problems with the data, being trapped by having sort of existing data processes that you don't understand and sometimes fail. And sort of the morning dread, sort of sitting, and I experienced this in 2006 and 2007, sitting in my car every morning, not wanting to look at my BlackBerry, waiting for something to go wrong with the thousands of people who are using our data. And I think we've talked a lot here about the stress and wasted productivity from sort of chasing errors and not having things perfect and also having your customers find problems. And so this manifesto is really about a method to watch over our data's complicated paths, kind of to avoid problems and errors and customer frustration, and also increase your productivity and increase your happiness. So I'm going to have just a few slides. There's 21 points here, and I'm going to go through each. And I think the first big idea is the difference between what should be and what is. And so when we build a data and analytics system, right, you've got a database and tools to transform data and languages and visualization tools. And you can and the difference between what is it running, is it late, is the data right, and what should be is often missed in an organization. And so you should know what should be. And then you should not hope that it's perfect. Hope is not really a strategy. Hoping things work is kind of a recipe for failure. And honestly, it's surprisingly a large majority of people run their data and analytics systems on hope or it's converse. They sort of wait for your customers to find problems, and that's just not okay. It's not okay to deliver something to your customer and have them call up and say it's look weird, and you go, oh yeah, it is, and I'll fix it quick, or I'll fix it in a month. I'm going to talk a bit about this, but we've got really complicated data architectures. You look at any data architecture, and it's just dozens of little boxes everywhere with servers and software and tools and links. And maybe this is pejorative, but it's kind of built on almost performative complexity. How many boxes you have are almost your cooler. And so when you have a lot of little boxes that are all working together, you need a mission control. I need to see if things are working through those boxes. And as all of us who've done data and analytics, don't trust your data providers. They're gonna, whether they whether they want to do it or not, whether they know they're doing it or not, they're gonna give you bad data, and kind of get used to it and protect against it. And don't assume what worked last week will work today. If everything ran great last week, well, the data could have changed. Some code could have changed. Some server could have had a problem. And then when you find problems, hopefully before your customers do, find the exact source in those little boxes. Find the instance of that little box and what workbook, what model, what job is running it. And I think a lot of people focus on sort of perfect data quality, is the raw data that we're getting. And that's really important, but it's not a cure-all. Even with perfect data quality, you still could have problems. You still could have errors. Because the data is being joined and put together and visualized, et cetera. And a lot of us try to test, which is check to see if things are right in a manual way. I'll eye it up and see if it's right. And sort of the idea here is to avoid manual testing of anything. Data, server, CPU, is the report showing the right numbers? Just avoid it like the plague, because it's causes it's sort of akin to hope. If it sort of works in development, it's guaranteed to break in production. And we've talked a lot about this in our books on DataOps, but really you're running a factory. And the lessons of Toyota and Lean and Deming, that every tool along the way, the ingestion tool, the transformation tool, the database, the model, the visualization, data prep tools, data governance tools are kind of workstations on that assembly line. And so you don't want to buy a car that is produced on a crappy assembly line that has a lot of errors, nor do you want insight produced on a crappy assembly line. And we've written a lot about a more general concept and wrote a manifesto years ago that I talked about. So excuse me. So I think we need a new idea, and that's called a data journey. And I think the idea here is that you need a layer kind of on top of what already is running. You need an expectation layer. And that expectation says, it tells you of all the myriad paths that data takes from where it gets into your organization to where it goes out to your customer. Is it right? Can I trust it? Is it on time? Does it make sense? And it's a layer that really observes things and doesn't run anything. Like we've got lots and lots of orchestration tools, and there's just another open source orchestration tool starts every week, right? And there's like 56 orchestration tools. There's 50 viz tools. Every data stack's there. And so really you've got to observe kind of across those tools and down the stack that they run. And so that across and down problem for every instance is hard. And that's really, you're not running those things, you're observing them. And when things go wrong in them, you want to know before your customers. So getting real-time status. And then kind of creates, what's missing here is the production context. And this is often sits with sort of a person on your operations team, and they know, maybe they've got a spreadsheet or a Word document that talks about, okay, this is run, and after this hasn't run, and they have, okay, we've got 50, 100, 1,000 jobs in their organization, and maybe they got an Excel spreadsheet because they use it, but there's no sort of context of what's running. And that context also requires that there's a lot of components, right? Your servers and databases and jobs. How do they all fit together? And here's sort of a literary reference of paraphrasing Anna Karenina. sort of all happy error-free data journeys are alike, and each unhappy data journey is broken in its unique way. So if you've ever read any Russian novels, you'll get that quote. And then here's another one that's also a very nerdy quote from the 80s. So Ronald Reagan said of the Soviet Union, "Trust but verify." And I think that's right. So trust comes from monitoring and checking the data in every tool on your data journey, and test and look for anomalies at every step. And then finally, this idea of your data journey and having a place to put it actually makes it really useful, right? One is that you can share it, right? Everyone wants to know the production schedule, and between the engineers who built it, the people who use it, and all the managers who get yelled at, like that schedule, the what's running, what will be running is really important. And then keeping track of what happened in the past, sort of learning from errors, trying to look at over the last 2 weeks, have we met our SLAs? Have we had any serious data errors? Where was the problem? What can we do to fix it? This idea of root cause analysis and being able to go in and look and learn. I think these are all great ideas. And so why would you want to do it? Well, I think there's two parts. One is that, of course, it reduces errors, and by reducing errors, it drives team productivity. That's the bottom bullet. The second is that it also can actually, by having a data journey that's sort of tested, you can use it in development. And I think that's great, right? And I think this also, the idea of a data journey to help regression test or do impact analysis is a good way to think about how data journeys exist from a similar concept called data lineage, which is a way, sort of a static analysis of your data system, but doesn't tell you if things are late or if the data is wrong. And so this idea of automatic, like any software developer knows, you could have a bunch of static analysis of your code, and it's good. It'll tell you, okay, the function is expecting a string and you sent an integer. That's really great. But nobody ships software just with static analysis, just like no one should ship data and analytics just looking at lineage. You actually need to run the system and test it to see if it's right. And that's where this idea of regression or impact analysis testing comes in. So let's kind of go to, that's the manifesto, and tell me what you think. We actually have it up on the internet now, so you could go in and look at it and see all these points. And if you're interested, you can sign the manifesto. And so thank you for that. And let me open up the thing and see if there's any questions so far. Great, there's no questions. So let's go back to our slideshow here. And let's sort of give some concrete examples of sort of why you need this. Now this is from Andreessen Horowitz. They're a top-notch VC firm, and they're also top-notch content creators. And here's all the little boxes, right? And so like there's all these little tools between reverse ETL and your data lake and your metrics layer and your dashboards and your embedded analytics and your sources and ETL tools, visualization tools. It's pretty crazy, right? Lots of boxes and arrows. And so somehow you're supposed to tell if things are working on that. And so I just think that's a crazy, it's a crazy piece right there, and trying to see across all of it. And I think that's one part. And then second is, like, every cloud now has the full stack of data tools, right? They have databases, they have ETL tools, they have viz tools, they have data science tools, they have catalogs, they have different types of database engines. And so just pick your pattern here. Again, the law of little boxes everywhere. And so, and there's different patterns, and this is normal, right? We're doing very complicated things. There's never going to be one tool that does everything. Little boxes mean there's lots of innovation. And so people love their tools, right? They love their little boxes. And a lot of times your individual contributors are on their team. That little box is their world, right? That's the thing. Their little box of working on, their little box of working on the ETL layer is that's what they do. And so these little boxes actually are important to people. And so I don't mean to diminish the innovation and importance of those tools. I just, happen to think that the whole system is more important than the individual part. And we take these parts and we actually arrange them in really complicated design patterns. Now, a lot of bigger companies have what's called a hub and spoke team. They have a central team that ingests data, maybe governs it, and then spoke teams who take data and do with it, transform and integrate it. You've got sort of data producers, data consumers, which is a very common pattern. You have the new modern data mesh, right, where there's sort of individual teams owning domains and the interconnection between domains, and then streaming, and in addition to batch, right? And all these things are great patterns, right? And you should try them, and they're sort of, and the reason you have them is because either your data has a high velocity and it has business value, or you're trying to organize these large teams to make them more efficient and more agile. But again, it's just more boxes and more links between boxes. And then interesting, DBT published this case of their models. And so, you know, it's sort of like places where data goes in a database. And 5% of the DBT models have over, 5% of the customers have over 5,000 models. And this is, you know, whether this is valuable or not, or they should refactor it and get it down to 1,000 models. This has been common, not just with, this isn't DBT's fault, right? The sort of spew of data happened. It still happens with Cognos, right? You have 400 Cognos reports, each of which have 20 embedded lines of SQL, and then they actually do data prep. Or, you know, there's companies who use Alteryx and have lots and lots of Alteryx jobs running to do kind of take the data from its raw format or semi-formatted and put it into a position to get value. And so again, that's follow the path through 5,000 things and find out where the problem is, let alone how those 5,000 things end up in models or visualization. And so what's a picture? So data journeys are sort of across the little boxes, right? Where you take raw data, it's batch or streamed, you place it in the database and you ETL it or ELT it, you transform it or clean it, and you use it, right, in visualization or data science or sense to somewhere else. And the characteristics are there's multiple tools, multiple data sets, multiple paths through those data sets, multiple jobs, multiple architectures, multiple customers, and multiple people. So that's a lot of word multiples everywhere, in addition to boxes, right? And then the other little thing that's problem about this, those boxes are not just, the boxes are deep. So the problem could be in all the way to the bottom. Could be in you got something in the lower right here off your FTP wrong. Or that could be perfect, and maybe your server is spinning out of control. Or maybe your tool isn't running. Or maybe the code that's existing in that tool, a YAML, a SQL, the workbook has a defect. Or maybe the thing that's running it, your orchestrator, fell over. And this is great if you've got some tests, maybe your tests are returning errors. And so all these, you have this sort of a cross and down problem in finding where things are. And that's the challenge here, because things will always go wrong. And so where to find the problem and fix it before your customer is important. And so that's sort of the idea here after 19 minutes. And I'm going to sort of talk about some of the principles here quickly. And so feel free to jump in questions. And so what are the principles behind a journey? Well, first is that you have lots of them in your organization already, right? Maybe you call them jobs or pipelines. Maybe you call them workflow, and you know, they could be sort of embedded in different teams, and they're batch and streaming and manual, and they're everywhere. And if you look at larger organizations, they could have hundreds, even a team of, you know, 3 to 5 people, they could have 20 to 50 of these things running. And the whole point here is you just want to know that they're running and know that they're right, and think about other things. And you know, we all have lots of tools, as I've talked about before. And so people have different tool chains, lots of boxes. There's lots of tools in every category. And I don't think I need to express this anymore. And then the second is there's lots of pieces that things run on. It's the across and down problem. And then data journeys, these pipelines actually fit in an organizational context, right? So you may have a central hub team who ingests data. They've got their own journeys, and then you've got each team in a sort of line of business running separately. This could be mapped into a data mesh context, or each are domains and the inter-domain relationships. But like, there's lots of hub and spoke dependencies here. And so data journeys themselves have a development process, right? You change them You want to get new code or new data or new changes to configuration into production. And so they have, and oftentimes that development process is different depending upon your organization. Maybe your hub team is a very formal multi-month SLDC, whereas your spoke teams are kind of just pushing a button and eyeing it up. And so this is also interesting and a source of error. And so, because we've got these organization designs, hub and spoke, data mesh, your data journeys end up following Conway's law, and that they all have to be, people own the data journeys based on how the organizational structure, not based on the, perhaps the best technical way to do it. And this happens in software, this happens in manufacturing. Conway's law is a very common thing. And so we talked about this, right? They need correlation. So if something goes wrong, right, you want to know, was it the raw data? Was it something happened when I put the raw data together with other data and integrated it? Was it because the actual predictive model went out of whack, or the visualization isn't making sense? Or it's just late and the server is getting pinned. And so all these things, and then what will happen, what's related to this that will break it? And so this idea of correlation across and down and between journeys is actually really fundamental and actually makes it complicated because of this complexity and coupling in these systems. And so oftentimes, as I said, that's not really anywhere in an organization. Like for instance, a very common case, if you look at how does one data journey relate to another? Well, one is causal. It completes, and then something, an orchestrator, a signal, causes something else to happen, right? That's in the upper left here. Sometimes it's temporal, like your ETL process has got to finish by 5 a.m., and then at 7 a.m. your dashboard build works. And they're uncoupled, but they're obviously related to each other. And then there's manual cases. Your airflow scheduler finishes at 1 a.m. and then your India team's got to press a button to do something at 3 a.m. And then there's ones that are more event driven. So something, new data drops, added in, update the dashboards. And then these relationships are complicated between journeys. They sort of fan in, where I've got a bunch of new data sets and I'm building the warehouse, or I built the warehouse, fan out, and now I've got a bunch of dashboards and data journeys that are related. And so this tribal knowledge, unfortunately, really isn't, it's not anywhere in an organization, and that's why it's crazy hard when things go wrong and you're having to take all your smart people and putting them together in a room, and that they're wasting their time trying to find out what the problem is, rather than having a journey just tell you. And so I think that the cornerstone of this is that you need an expectation layer on what is happening with your with the production of analytics. And expectations could be on logs, could be on errors, could be on metrics, they could be on data tests. And so you need to judge what is versus what should be. And so let me, someone asked a question. Let me finish this expectations, and I'll answer the question here. And so, so journeys react to events and notify. And so what's happening in your system, the sort of living, breathing, data moving from place to place, something happening with data, results being pushed to customers, this is sort of living and breathing and going on. And so what's the variance between what should be and what's not? Like, obviously schedules and durations and dependencies, this should have run before the other thing. And then trust, like, is it trust? And so that variation between what you think should happen and what is the source of a great way to notify. And so, because you've got this database of what happens, you can actually do some historic analysis and look at it and say, well, what did happen? And what happened last week? What happened last month? And where are we? And sort of looking at it from the boss's context. How many tests did you have? How often were you late? And then this idea of context, right, between someone who does the work, right? Maybe I'm a data developer, a data scientist, or engineer. Maybe someone who runs the work, a production engineer. maybe someone who manages people, and then maybe someone who uses it. Like they're all interested, is this working or not? And so this shared context is actually really important for people, and oftentimes it's missed. And some people try to do it right. They'll have a run table and they'll manually create them things, and that's very helpful. But it saves a lot of time if you can give the pulse of what's going on with everyone else in the organization. And so I guess the question is, we saw a lot on analytical data, but how can we approach transactional systems to apply some data journey on it? And I think that's interesting, right? Because I'm primarily talking about analytic systems. And what that means is there's a transactional system like Salesforce CRM or your company website or an ERP system where people are trying to put data in a very highly normalized form. And data and analytics, we take data from that and try to answer insight questions. And so how do you actually sort of push back on your transaction systems to find out if it's right? And I think that's actually a really good point. Is like, and something I believe is that you just don't trust your data providers. And so the journey starts with them. And how do you actually improve their data, both the quality and the errors that they have? And I think that comes from having and the ability to find out problems in data very quickly. And so, and the sort of software systems that build sort of three-tier architectures where you've got a front end and a back end, and they test their transactions, and they don't call it a data journey, that they just call it a regression or an end-to-end test where someone puts something in the UI, it goes through the UI layer to the database, and they see that the data's all right. And so they have kind of a concept of the front end, back end, end-to-end test that is sort of equivalent to a journey. But really, I think journeys, one of the benefits of making sure that your data is right as soon as you get it. A data journey is making the first step of your data journeys right. I think that's a very helpful thing to do. And so this is an interesting diagram showing like there's just lots of problems and potential problems in data, right? If you look at all these cases where you're watching a file and putting it in a warehouse and putting it in a dashboard and a model, and where is the problem, right? Was there a file count mismatch? Was there an external refresh that failed? Was there some legitimate or illegitimate shift in the model prediction? Is there some business rule that doesn't make sense? Like, do you suddenly have twice as many sales as you had last week? And so is the schema different? Is the file format different? There's just a lot of places that you could find these problems, right? And so the point of a journey is to say, okay, which one of these red boxes is it? And where can I find it quickly and hopefully fix it before my customers do? And then the last idea, I think, is that these journeys themselves have a use in development and being able to do development regression testing in addition to production. And so, so that's sort of the kind of summary here after a half an hour. And so the idea is that, we are missing a piece. That piece is the concept of a data journey. It's something that is your expectation layer on top of all your systems. It tracks as an instance each one of these paths that data takes through your organization, and allows you to store that data, get notified of that data, set expectations on that data. And so being a software company, we've instantiated these ideas into a piece of software. And so what I'd like to do is spend about 10, 15 minutes showing you that software and discussing kind of how we did it and why we did it. And so if I kind of go into that and show our software, so let's go in and I'm just going to show this data journey. And so here's one. And what's interesting is there's sort of a bunch of tools. There's Azure Data Factory that's putting data in. It happens to use Databricks as the database that run it. There's a Databricks notebook that runs. There's a Python file that runs, and then there's a Tableau dashboard. And so your customers sit at the right-hand side here. And now remember, a data journey doesn't run anything, right? It's sort of a collection of expectations. And the first expectation is, well, Azure Data Factory's got to finish before Databricks and the models run. And then they have to finish before Tableau runs. That's one level of expectation. And the next is that they ran, that they started and stopped and there wasn't errors in any logs. And then the third level is like, what's going on inside of these things? Is the data correct? hasn't been loaded right? Is the Tableau dashboard showing those things? And so the important thing is to collect all that information and start to understand the timing of them. Start to understand all the events that happen on it. And so in this, we're collecting a whole bunch of event types, like for instance, just messages and logs. Those are actually really interesting things, like, hey, it ran, or hey, there was an error. There's run status. I started and then I stopped. Outcomes of metrics, like here you go, I've gone in, and if I want to look at different, like a metric event, I can actually go in and see the number of files written, the amount of data written. I can look at various messages in here, just what's running, what's not. And then I can look at things, what are called test results, which are ways to actually check tests. And here we've got some test outcomes. And so what we do is bring all that together and then allow you to say, well, what happened? Here's the, I've got my Azure Data Factory job running here. And what job is that? And links this into whatever tool you happen to be using so you can dig more, because the tool's doing all the work, right? You're just observing it. So being able to go in and get at it is important. And so, you know, this sort of data journey collects all this information and collects all these events, all these tests that are running against it. And we're going to talk a little bit about tests, and puts them all together into a way to look at the world. And then there's ways for you to actually go in and judge what happened when the world doesn't meet that. So for instance, when one of the components in a journey fails, well, I get an email. When journey has a late start or a late end, well, we call, for instance, a specific Slack channel. And then the third is like when the server capacity is greater than, say, 75%, you get an email. And that may not be an error, that may be just a notification that you go on. And so being able to look at schedules and timing and order and metrics across the tools and down the stack, and be able to make alerts off of it, I think is important. And so all these things kind of go into a data journey, but seldom does one company have one data journey. You actually have a bunch. And so let's look at this case here, and I'll show you a slide to kind of talk about what I'm about here. So in this case, we've got sort of, in the example, there's a nightly exports. They sort of have a data factory pipeline and then some Azure logic apps that do the export. We got an Airflow DAG that does the daily data load. And then after it, you've got sort of what I just showed you, the dashboard and the model. And you know, there's some databases and, you know, using the typical bucket stores. And what happens when you don't do this, right? You can get data errors or tool failures. You can get downtime on one of these that they're not running, and that's the red box I showed you. It's difficult to judge the impact when something goes wrong, and your customers find problems, and you have much longer resolution time, and you end up kind of doing the same thing over and over and over again. So going back to the product, well, we found the nightly exports, well, it had a problem. So let's kind of go into that and say, well, what was the problem here? Well, Azure Data Factory had an issue. Okay, well, let's go into there. And I can actually see the instance of Azure Data Factory. And oh, the third step in that Azure Data Factory, that data transform, had an error. And that shows up in my list of events, that there's a specific error, and that actually came from one test failing. And so that means that everything ran, everything's great, but the data in that was not right. And so that's, again, one of the reasons why you want to pull this together, is that things are running, logs look good, there's the right amount of disk space, but it ends up not being right. And that goes to checking and making sure things happen. And so that data export failed, and now you can know about it and get events on it. And then let's look at the next case, a daily data load. Here's another tool, an Airflow job. And so what this does is actually run an Airflow job and builds 5 tables, and sort of think of it as a dimension.mark, order, customer, some you know, some healthcare provider information in a fact table. So it builds this sort of simple 4-dimension fact table, right? And what happens is Airflow's loading this, doing some transformation, and every time it runs, it makes these tables. And so in its run, here's the last ran that happened. this is what Airflow looked like. It did this sort of step-by-step process, each step that happened. And there's a bunch of events that happened against it. So each one of these run statuses were good, right? We found that it ran, that it's good. And if something goes wrong, well, maybe we can go off and dig into the Airflow job to find out what happens. And here we're actually running each one. But that, the problem with this is that, it runs, but you don't know if the data's right. And so you've actually got to check the data or test the data. And that's what this box at the end is called Data Kitchen Test. So let's go back and look at this and actually say, okay, for this instance, of the daily data load, I've got these 5 tables. How do I know these 5 tables are right, that the data's right? Well, we've got a bunch of tests. And so here we've actually got 791 tests that run. And so all of those passed, and there's a number here that have warnings, meaning something's wrong. And there's a bunch of specific tests. And we've got a new tool that we're releasing next month called TestGen, that actually generates tests for you and be able to go off and write those tests. And I think that's a really important part of helping people is, you can profile. Some tests really need to be developed because they're based on your customers, et cetera. But some tests are just based on the syntax of the data. And so for us, we've got this idea of, think of testing in sort of 4 buckets or 5 buckets, right? One is sort of profiling your data to help you understand it, right? That's one aspect. And then reprofiling it as time goes on. And the second is like, is the data different than the profile? So you have a column, it's got 3 values. When you first profile it, you get a 4th value. Could be wrong, could be right. You should know about it. And then there's sort of more fill in the blank tests. Maybe as a data engineer, you don't know all the business logic. And can you have some simple ways to give that logic to a data steward or someone else to sort of fill in the blanks? And these are more business rules, like what should the increase in our sales be every time we update. And this is our new product called DataOps TestGen. And then it's not enough to actually test just the data. You have to test the things acting upon the data. And so you have to test Python code or test the REST API. And let me just go into that a bit here and talk about this. And so we've got the dashboard and model production, right? It's got a Tableau dashboard and a Python model. So you go into the Python model and say, well, did it run? Yeah, it ran, and it had some tests that ran against it. And so I can look at it and see the events, and I can say some tests came. And if I go into those tests, we actually have our DataOps automation tool that's doing the testing here. And so here's the machine learning model. And so, models are very funky, right? And then they're very specific. And here we're actually running a model in a container, and we're just testing the sort of data going in it, but we're also testing the root mean square error of the model. And we're doing that because it has to be custom. The data scientist writes their model, they have specific parameters, and they actually even have their own favorite language to write in. And so actually interacting with the model here, the data scientist likes to do things in Python. So we're using a Python script to do it. Doesn't have to be, maybe you like SQL, maybe you have your favorite tool, but the test here is saying that the root mean square has to be less than 60, and 60 is a number that comes from the data scientist, and this RMS variable actually comes from that Python code that you saw. And so the idea is that you can't, in the system, you have to prove that everything works. So proving that your dashboard is right or your model is right. Don't hope, right? Hope is not a strategy. Trust but verify. Make sure, and the verification is at multiple levels. Did it run? Did a metric trap, or is the data or the thing acting upon the data correct? And so that's why we bring it all together. And so lastly, once you have all these data journeys and you've got the overview, you get this dashboard that you can actually share with your business users, right? But you can also kind of keep track of what happened and learn from it. So we have a dashboarding functionality here that actually allows you to look at it. And so what I've learned managing data and analytic teams is trying to, you've got, as a leader, you've got sort of 2 views. How good is your team and how do you show that up? And that's looking at, is everything on time, right? And here's a metric saying you had 141 data journeys this last week, and 81 are on time and 60 were late. So you've got a database of that. Likewise, being able to go in and look at data quality, being able to look at the number of tests. And so in a month or two, we're going to replace this with a more generic dashboarding feature, because being able to sort of look across all the dimensions and being able to go, but being able to go in it is also a feature. But these sort of standard dashboards are a way to help you kind of understand the data, show off how good you are, and be able to help your team think about how the work that they do is good. And so lastly, just to say, we've got 3 products now. We have the observability product, which I demoed, the test gen, which runs against databases and generates tests for you, that we're going to release in a month, and then our DataOps automation. And so conceptually, they look like this together. We've got observability, which is really just a simple REST API that you can program against. It's got an integration agent that actually is really quick to set up. So for instance, a few weeks ago, we had a customer start up. They put the integration in, and within 15 minutes, they had sort of 60 components in their system, all pumping data in, looking at what happened. And then building the data journeys was a pretty simple a process to be able to connect all the pieces together. And then sort of writing tests, well, we've got 2 tools, one for APIs and REST, and one that generate tests. And of course, if you've got your own test tool or have written your own tests or want to use one of the other data observability tools that does testing, we're perfectly happy with that. And so kind of like putting it together more in a concept picture here to go to a slideshow, just to look at our use cases. So for instance, you've got data coming in on the left, maybe using Airflow to load, maybe you're transforming it in dbt, maybe you're doing some predictions in Databricks and reporting in Power BI, right? And here's your data and your infrastructure. The first thing is we've got a test tool that actually tests your data in your database, and that sends it to observability. We've also got the automation, which will test your tools and send it to observability. And then just sort of monitoring things like logs and errors and runtime and schedule also goes. So pulling all this information together and building the data journey layer is what our software is meant to do. And these other boxes are optional products that allow you to sort of connect and test. But if you've got that already, that's just fine with us. And so lastly, sort of why should you care? I think the top bar here really matters. Is that if you look at an organization, and we've done surveys with Eckerson and I think Gartner, is that people are spending a lot of time on fixing broken stuff that doesn't have to be broken in the first place. And so when you're fixing production errors, you're not doing good work. And that is a big eater of teams' productivity. And then second, if you can't change things quickly with low risk, then you're not responding to your customers and you're doing work you don't have to do. And so the idea of observability is sort of drive down production errors. And that's a big part of the sort of productivity benefit that Gartner and we've seen. And so lastly, the conclusion. If you're interested, sign our manifesto. There's the link at the bottom. You'll be on our email list, but we've had over almost 20,000 people sign the DataOps manifesto, surprisingly. And then lastly, there's just a bunch of links here. We've written 2 books on DataOps. We've written a manifesto. We've written a bunch of things on observability and a data journey manifesto as well. So thank you for the time. And I see some questions, and let me answer those questions here. So another question is, are you able to access the PowerPoint? Sure, I'm going to share the PowerPoint, a link to these links, and a recording of the session here probably tomorrow or the next day. And you'll get an email, and then we'll also post it on our website. And another question, do we provide a free trial? Absolutely, yeah, we provide a free trial. We have a 90-day free trial on our website. We also try to use our observability tools in production to prove that they work. So I hope this was good. We talked a lot about different things about observability and the manifesto, and trying to help you be better and have your teams have less errors. And that's really the key, I think, to teams being successful. So thank you again. I'll email out these slides and hope you have a great rest of your day. Oh, wait, okay, awesome, thank you. And so is there a link that the services, the tool should connect to? There's one more question. Yes, there is. We can provide that, and we're actually going to have it in our next release. That link's going to be in the UI. And one of the nice things about the observability tool is we have a 15-day SLA. So if there's a commercial tool that we don't yet support, we'll incorporate it in within 15 business days. Again, that's it. Thanks, everyone.